Hello students, welcome to the next video on the chapter Elements, Compounds and Mixtures for Class 8 Chemistry. If you remember, we have read about many separation techniques of different kinds of mixtures. Today we will be dealing with the liquid-liquid mixtures. So let us begin. So when we are talking about two liquids which are mixed together with each other, they may be a homogeneous mixture or they may be a heterogeneous kind of mixture. So you know that a homogeneous mixture means the mixture is completely uniform throughout, and when the components or the substances are not mixed properly or are not uniformly mixed, then it is a heterogeneous mixture. So when we talk about separation of a homogeneous mixture, and what may happen is that the two liquids which are forming a mixture, they cannot be seen separately and they're completely mixed with each other, and that kind of a liquid is a miscible liquid. So like if you mix alcohol and water, they form a miscible and homogeneous mixture. So for that we can go for the technique of fractional distillation. And if you have a heterogeneous mixture, like maybe if you have oil and water to be separated, then they don't mix with each other completely, and that kind of a mixture is immiscible, and they are heterogeneous mixtures which can be separated by using a separating funnel. Then we also will be reading about the gas liquid mixtures, which again can also be separated from the fractional distillation method, and also we will be talking about the gas mixtures which can be separated by various techniques like liquefaction and solvent extraction. So let us get an idea of all these techniques. Now if I am talking about the fractional distillation technique of separation, in this, suppose we are having the flask, and in that we have the separating column. We have a separating column fixed in it. To check the temperature changes, I am placing a thermometer, and this system is connected with a condenser, and the liquid is coming and pouring in another beaker here. Please don't mind my diagram, this is just to make you understand. And we are having a pipe which is connected with the cold water. This is a condenser, this is a fractionating column, and you can see the mixture of alcohol and water here, and we are heating it up. It's kept on a tripod stand, and we are heating it up with a Bunsen burner now, and it is all connected to a stand. Now this is a rough diagram of a fractional distillation which I am going to explain. So here when I am having a mixture of alcohol and water, and they have to be separated by this fractional distillation technique. So what happens is, you know that alcohol boils at a temperature of around 78.4 degree and water boils at around 100 degrees Celsius. So when this mixture is heated here, the alcohol will obviously vaporize first, and through this fractionating column it is going to pass into this condenser, and the water is going to be cooled here as it passes through the condenser, and it will accumulate in the beaker or whatever flask you have kept this side. So the alcohol vapors are collected first, and then what we get is pure alcohol, because at 78.4 degree the alcohol is only going to boil off, not the water. So when we use this fractionating column, this method becomes fractional distillation. And also you might have heard that crude oil is separating, like many components are there in crude oil like LPG, petrol, kerosene, etc., which is separated by this kind of a fractional distillation method. And also remember, for the optimal separation of the components here, miscible components, difference of the boiling point for this kind of a fractional distillation. Then as I was talking about the heterogeneous kind of a mixture, that is the immiscible mixtures. The immiscible mixtures consist of like oil and water, kerosene and water, so they don't mix with each other. So for that kind of a separation we use a special device called the separating funnel. So if I show you the rough diagram of the separating funnel, this is something like what it looks like. And here the main principle of separation is that the method is working when the two liquids are immiscible, means they don't mix into each other, and the heavier liquid will settle or come towards the lower end. So here, if this is water, the heavier part, and oil being the lighter part, will come above. So it will form two different layers. The heavier liquid forms the lower layer, the lighter liquid forms the upper layer, and this kind of a heterogeneous mixture can be allowed to stay there for some time, and then it will separate out properly into two layers, and then you can open the stopper here and allow the water to be collected first, and then you can collect the oil. So that kind of a separation using the separating funnel, we are separating the liquid-liquid mixture which are immiscible and heterogeneous. So next we go to the separation of liquid-gas mixture. Now you know that when a liquid is containing certain gas, like mostly you know that water has air inside it, and if you have seen that when we boil water, what happens, the gases, they start coming out, they start escaping in the form of bubbles, and you can see it is changing into vapor and moving out. Similarly, when the mixture of liquid and gas is allowed to stand for some time, the gas generally moves out. Like if you take a glass of carbonated drink, suppose you have a soda, you know that soda contains carbon dioxide, and if you keep it out in a glass, you will see after some time the gas has escaped and the soda is tasting very bland, it has no taste anymore, and the carbon dioxide has escaped and there is no fizz in it. So if you allow it to stand also, it gets separated. Even mist is a mixture of water and air. It gets separated when the water, because it's heavy, that settles down on any object and the air has escaped. So by allowing it to stand for some time, we can separate generally the liquid and the gas mixture. And also there are many other techniques for doing liquid gas mixture separation. Now we next move to the separation of gas. You know there is a technique called liquefaction, which is actually the gas is changing into liquid. That process is liquefaction, and it may happen because of the pressure applied on it or the change in temperature. So when generally pressure is applied, a gas changes into a liquid, and it can happen at different pressure levels. For different gases, the pressure applied may be different, and one gas can liquefy faster and one can liquefy slower, so it can be separated then. And when the temperature is also decreased, you can see a gas changes into liquid. You know that when the temperature of oxygen, it is decreased below minus 183 degrees Celsius, it becomes a liquid. Similarly, nitrogen, you know that liquefies at below minus 196 degrees Celsius. So by using that technique of liquefaction, we can separate the gas-gas mixture. We also have a solvent extraction technique which can be applied for gases also, because some gases, they dissolve very well in some solvents, while others they don't dissolve so well. And this property of gas can be used to separate the gas and the gas mixtures. So also remember that there are multiple methods. Sometimes it is not enough for just to use one method to separate the components of the mixture, but we need a series of one or more methods which can be used. So I'm very sure you might have understood all these techniques well. Thank you for watching.